This is amazing. I'm just taking a minute to enjoy this. This has taken years. It's quite emotional, actually. Listening to my friend Hagop recount how this journey started. 2018, when I first met him, along with the Prime Minister. What I told him when we first met is that for Armenia to exist, for Armenia to be viable, for Armenia to be prosperous, the only chance we have is to take advantage, to capitalize on our only natural resource, our human brains. The brains that are in this room, the brains that are in our country, they're the finest brains that I know. But we need to find a way to turn that into our strength, into an engine that can create an economy that can ensure that we have security, that can ensure that we are important to the world. So we are not just some little country that goes around begging for others to take pity on us and to take care of us. They come to us because we have something to offer to the world. These brains that we have, the only chance we have of actually turning it into value is through technology. It turns out that technology is the most valuable product in the world. I happen to know this because I work in the most valuable company in the world. And the product of our company, of the 42,000 people that work in our company, is just ideas. It's just our thoughts and knowledge. I know that we are capable of doing great things, of being world class, of being important to the world. And so this journey started with that basic idea. The idea that we need to develop our brains so that we can become valuable. Essentially, the only industry that we can participate in to do this is technology. And the basic instrument of the future at that time to produce this technology is an AI supercomputer. This is what my CEO, my good friend, and my mentor, Jensen Huang, told our Prime Minister when we first met. He said, if you want to develop the infrastructure, you want to develop the minds in your country, you need to give them the right tool. And this is the tool. Nobody understood it at the time, but it didn't matter that nobody understood it. We kept going. We kept bringing this idea forward, and with forward-looking people and people who really believed, like Hagop, we pushed this forward. Thank you, Ruben. Thank you to the Minister, Mkhitar. Thank you to all the others who have worked so hard and come together to bring us to this moment. And with that, let's get my actual talk started before I start crying here. So we've been talking a lot about AI already. There's many discussions about what AI and how it might impact us. There's going to be a lot more in this conference. You're going to hear a lot about it. But first, let's take a second to understand what the origins of AI are and how it's been developing over the last decade and where we are today and where we are going. This whole thing started a little over 10 years ago with a neural network that was developed, the first era of deep learning at the University of Toronto. Two graduate students and their professor, Jeff Hinton, who is called the godfather of AI, kicked off this whole AI revolution with one neural network that solved a problem that had vexed computer scientists for 50 years. For 50 years, we didn't know how to look at an image, have a computer look at an image, and tell you what's inside that image, to classify it, say whether it's a dog or a cat or a human. And in one moment, this long-standing problem that we never thought could be solved was finally solved. That essentially started the whole revolution. For the first time, we were capable of solving this problem. What was most interesting wasn't that we solved that problem, it was how we did it. We solved this problem not by having a computer scientist, a computer programmer, write the rules into a program that solved it. Instead, what we did is we took a supercomputer and we gave it examples of what we would like this software to do. We showed it millions and millions of images that were labeled with cat, dog, airplane, etc. And the computer, the supercomputer, wrote the software for us. This was the fundamental change that basically has changed everything. To this day, we don't know how to write a program that could solve the problem of image classification, but we know how to write a program that we can run on a supercomputer, that we can train using examples of what we would like it to do. And this new way of writing software changed everything. We now need supercomputers in order to write modern software, and we need data to all the examples to go feed it. It all started with AlexNet, which kicked off the first era of AI, which we call perception AI. These were small models that do very specific things, mostly perception. They can tell us about things inside images, they can interpret audio and sound and interpret things in the world, which is already pretty magical. That led to the next era. This is the era of generative AI. Most of you experienced it at the end of 2022-23 when ChatGPT came onto the scene. For the first time, we were able to take this new technology and generalize it. We could create a very large model that did more than one thing. It can do many, many things because it has some type of general intelligence. This is the era we've been in for a long time, and I've been talking about how we're entering the era of agentic AI, which Hago Parshakian just learned about at GTC. But now we are firmly inside this era, and I'm going to be talking a little bit more about that. Each era is built on the previous one. The agentic AI era is about taking this generative AI technology and giving it agency, allowing the AIs to not only understand their world and their environment, but to go act and go do things for us, which fundamentally changes how everything is going to be done and how our economy is going to be built. The next era that's about to come, and the one where I'm focused, the one that the video I just showed you, besides being pretty pictures, is really about, is about taking this AI, the agents that can operate inside our digital world, and giving them physical bodies so that they can act outside in our physical world, which is ultimately what's most valuable to us as humans. As great as the digital world is, we actually live out here in this world of atoms. And in this world of atoms, we basically haven't benefited from computing almost at all. We only have applied computing to to the world of knowledge and ideas, to the world of language, to things that are naturally digital. But that is about to happen. For most people, when we talk about AI, they think about ChatGPT or some kind of chatbot, LLM sort of thing. And we think that the AI is basically the model. We always talk about these AI models, GPT-3, GPT-4, 5.6, Claude, Grok, et cetera, et cetera. Those are an extremely important part of the AI ecosystem, but really AI is far more complex than that. We like to talk about it as a 5-layer cake, of which the model is just one layer. At the very base, what everything is based on is energy. AI is fed by energy. Without energy, you cannot have it. So you are fundamentally limited by how much energy you have. On top of that, we have the chips. This is the other part of AI people start to think about a bit. They think about it mostly because NVIDIA now is worth almost $5 trillion. And they think of us as a chip company, which is partially correct. But chips is a critical part of that. We take the energy, we use the chips to convert the energy into intelligence. On top of that, we have infrastructure. These are the massive AI factories, that new word that we introduced that Hagop had mentioned. And there's a good reason for why we call them factories and not data centers anymore. And on top of that infrastructure, we then have the models that most people think of. But the most important part, the part that really needs to be developed, is the layer on top of that, the application layer. This is where we take this raw technology, these capabilities, and we turn it into things that are actually meaningful for us humans. We apply these great capabilities to solve actual problems and to solve things that matter to us outside in the real world, whether it's science, whether it's our business processes, whether it's agriculture, our food production. Everything can be affected by intelligence. And so this is where we need to focus the most. And I think for most people in this room, this is where you're going to be playing. You think of NVIDIA as a chip company. We talk about chips a lot. Chips are very important. And we're the best at making chips in the world. We are world class at it. And we're very proud of it. But it's only part of what we do. We take these chips, we build them into systems. Some of these systems are right here in the basement of this university. I was just taking a tour of that. We started on the journey of building systems over 10 years ago because we understood that in order to solve this AI problem, it wasn't going to be sufficient to just throw some chips out there. This is a full stack problem that requires the whole 5-layer cake. And then we started scaling it up. The computers that we build today are not in a box like you normally think of a computer. The computer is actually a whole building or multiple buildings. We design these computers that are at these huge physical scales, all acting as one machine. And quickly, we are now turning into an infrastructure company. It's not sufficient to just build the computers that go into these buildings. We are part of an ecosystem that is designing all of the infrastructure, including the buildings, the power grids, our supply chains, both upstream and downstream. So what does this 5-layer cake mean for Armenia? Well, it turns out Armenia already is participating in AI at every layer of the 5-layer cake. You can take a look at some of the logos up here of the many companies that are already in Armenia. Some of them are international companies that have a presence here, but many of them are homegrown companies, and there are more forming every single day. We are working at every level. The application layer, as you would expect, is the largest portion, but increasingly we are starting to participate in the layers below, which is very, very important. And I believe that many of the people in this room, if we do our jobs correctly, will be contributing greatly at that level. This is an advantage that we have now because before most of the world has this kind of AI infrastructure on their soil, we are getting it here in Armenia. That's an opportunity for us to learn how to build at that layer that many others don't have. So why do we call it an AI factory and not just data centers? The word data center implies that it's about data, which is largely what data centers have been about. This is where we store data. They're kind of like warehouses. In the physical warehouses, we store things inside there and then they don't do anything. It's inactive, it's passive. And occasionally, when you need to go access that data, we transmit the data. We just move data around back and forth. We serve it on the web in one way or the other. You store your videos, and then occasionally you go play a video off of that. Inside these data centers, the classic ones we have, there isn't a lot of work being done, so you don't need a lot of computation. The computation is what requires energy. And the way you design a data center for data is going to be very different than what we need today to produce AI. For AI, everything changes. What we are doing in the data centers we put these AI supercomputers in is we are converting this energy into intelligence. We're doing a lot of work. Doing work requires energy. Fundamentally, it's exactly like a factory. A physical factory that manufactures products takes as input energy, raw materials, applies that energy to convert those raw materials into a finished product, and that finished product that comes out of the factory is far more valuable than the inputs. It's more valuable than the energy and the raw materials you put in there. That's how you create value. So when you operate a factory, when you build factories, you actually want to build as much as possible because you are adding value to the world, and if you're adding value, you're making money. For warehouses, you actually want to minimize the cost of those things. Normal IT data centers are about storing information. It's part of your IT department. It's just the cost. But a factory is at the center of your business. And so what we are producing here is what we are manufacturing are what we call tokens, which are the basic units of intelligence that come out of these AI factories. And the name of the game is being very efficient. Taking your energy, taking a watt of energy and converting it into as many tokens as fast as possible with as much uptime as possible, because every token you don't produce, you're losing money. To do this, we are designing these supercomputers at the scale of infrastructure. We are working at the scale of gigawatts, where we have everything from the power generation and the power grid all the way down into the transistors on a chip, all optimized and designed together to maximize the amount of tokens that we can produce. The reliable tokens at the highest quality tokens possible as fast as possible. To do that, we actually use supercomputing. We have to design all of this, everything from our chips all the way up to the infrastructure level. We have to replicate it inside the computer to do a simulation, to create a digital twin of that, so that we can test everything, design everything before we realize it into the physical world. We do it inside a computer, optimize it together, and put it out. Once we put it out in the real world, it just works. And it works efficiently, and we can iterate faster and faster than anybody else can. This, by the way, is the key to NVIDIA's success. Fundamentally, from the very beginning of NVIDIA, we have invested deeply into our own simulators to simulate our chips so that we can develop our chips and design them faster than all of our competition, knowing that when we finally go put them out there and manufacture them, which is very expensive, they just work and they work perfectly. This is an area that all of you should be thinking about. So once you produce this compute, these tokens that we produce are actually directly correlated to revenue. Essentially, you're producing money. We're taking energy into the factory. We produce these tokens, which are of high value. And these tokens represent intelligence, which quite frankly is probably the most valuable thing we could ever produce as humans. This is what I was talking about at the beginning when I stepped on this stage. There's no industry that you can think of where you might say, I think we have enough intelligence here. We don't need any more. Intelligence isn't going to make it any better. You can always use more. Essentially, the demand for intelligence is infinite. You can always produce more. And what we're starting to see today is this infinite demand coming into play. We're seeing the demand for intelligence connecting into our ecosystem. So this demand for tokens is growing by orders of magnitude. What has happened in the past few months has been staggering, even in the past few weeks. Many of you hopefully have been playing with some of these new AI coding agents. This agentic era has started. These agents are creating demand that is off the charts. I'll explain that in a second. We are producing these agents in two classifications. We have agents that operate inside our digital world. Those are the first ones we're using, like these coding agents. But we are in the process of also taking these agents and bringing them into the physical world. The way to think about these agents in terms of economics, in terms of a country, in terms of our GDP, is that they are not tools that just augment the population you have, which is traditionally what technology has always been. Whenever we introduce a new technology, it takes your humans and it makes them produce more. It amplifies them, which is a great thing. But these agents, because they actually operate on their own, you can give them a task and they go participate, they're more like actually adding an employee. They're more like adding another citizen into your country that can produce GDP. They can produce product. For Armenia, this is essential. We are a small country, only 3 million people, and fundamentally, no matter how much technology we have, how many tools we have, there's a hard limit to how much we can produce. But if we can produce agents and convert energy into tokens that produce more and more of these agents, we are essentially adding population to our country that can help us produce GDP. We can have millions and millions of other workers, both digital knowledge workers and physical workers, join us. But in order to do that, you need your 5-layer cake, and you need all of the layers to be as big as possible. The base layer being energy, and this is what we're working on in Armenia to unlock here. On top of that, you need our infrastructure. So in terms of demand for these tokens, in 2023, when ChatGPT had the explosive growth, we saw our first surge of demand for tokens. This is what fueled NVIDIA's rise. The demand for our chips, for our infrastructure just went through the roof, and we became the most valuable company in the world just based off of that demand. A year later, we introduced, OpenAI and others introduced reasoning models. These are models that didn't just give you a quick answer. They could actually go through a chain of thought. So essentially using more and more tokens to go through more and more thinking, much deeper and for much longer. That increased the token usage, the amount of token demand you need to create this, by at least 10 times, probably more. And now in this agentic era that we've introduced, we have agents that think for very long periods of time that spawn other agents. They can actually create new workers to go do things for them. And we're seeing 100,000 times the demand for these tokens. Essentially, we're at this moment today, by our estimation at NVIDIA, if we do our job as to the maximum, produce as many chips as possible, there will still be more than 1,000 times demand for tokens than what we can supply with our chips. We are at a point now where the demand is always going to be greater than the supply. And so fundamentally, the work that we are the work we can do is only going to be limited by the layers of the stack and your energy. That is the fundamental limit. So this is a good place to be, and it's a good place to be for us. You can see this happening in the past few weeks, in the past few months, from many different angles. This is one of my favorite ones. So here you can see a chart. This is the number of stars on GitHub where open source development is happening. Linux, which is the foundation of the modern internet, it's the operating system used for just about everything, is the blue line. You can see from 2012, you know how long it took to get to 250,000 or so stars. And then there's Facebook React, which is basically the foundation of all of the web user interfaces that we all use. That was a little bit faster from 2014 up and surpassed Linux. That red line that looks vertical is actually not vertical. It's just in the past few weeks, OpenClaw, which was an open source project that introduced this new agentic era, kind of the ChatGPT moment for agents, came on the scene and surpassed all of them almost instantly. So with that, I'm going to give you a little video to show you what some of these agents can do.
An open source project just dropped.
Andre Karpathy has just launched something called research is a huge deal.
You give an AI agent a task, go to sleep, it runs 100 experiments overnight, keeping what works and killing what doesn't.
I really love what my stuff enables that person to do. And we had like one guy, he told me like he installed it at his 60-year-old dad and like they made beer, connected the machine via Bluetooth to OpenClaw. And then we automated everything, including the whole website for people to order.
Lobsterlager fertig sein.
Everyone is talking about OpenClaw.
OpenClaw. We want to build OpenClaw with OpenClaw.
What is OpenClaw?
Hundreds of people are queuing up for lobsters in Shenzhen.
Believe it or not, there's already a claw con.
So for most of you, you probably don't know what OpenClaw is or agents, but I'll give you a very quick little summary here because I know we don't have that much time left and we want to keep this open for questions. This is probably the most consequential invention, the most consequential change in computing in our lifetimes or probably ever. We now have the ability to take computers, have them produce intelligence, and have them actually go do things for us and work for us as employees, as workers inside our environments. We're seeing it first in the digital space, and soon we'll see it inside the physical space. The way they work is actually the same way humans work. They use tools. They use all of the tools that we've already developed for ourselves. They can come in there and operate for us. And we're now just starting to learn how to interact with them, how to deploy teams of them, how to scale them. What's happening is very quickly we are going to see our IT departments essentially turn into HR departments. They're going to become HR for our artificial employees. We're seeing agents being deployed out in all of the major software systems, software tools that are used to go build everything inside our world. Here's some of the companies that we are working with closely at NVIDIA to bring this AI and agentic AI technology into their offerings. And pretty soon, these companies that produce tools that humans use are going to be producing employees that we can go rent or hire to use the tools that they build, but use it for us. Some of these companies are actually present here in Armenia and work here. You can see Siemens and Synopsys and so on, and Cisco. And we'll be inviting more of them to come join us here as we become experts at using AI. They're going to need our help to move into this agentic era. I mentioned that we are in the agentic AI era. These agents are robots, but they're robots that just use computers. They're like knowledge workers, like most of us over here. Most of us don't work with our hands anymore. We work with our minds, and we maybe type. That's about as much as we use our hands. But where we're going to see the most value is when we take these agents out into the physical world to come do things for us in agriculture, in manufacturing, in all of the stuff that we actually pay good money for. We pay for food, we pay for physical products, for cars, for things. We pay very little for IT sorts of things, relatively speaking. The way we are going to produce these physical AI, these AI agents, is by using 3 types of computers. The first thing that you need to do is produce a brain that you're going to place inside the robots that are coming out into the physical world. To produce that brain, you need exactly the same type of computer that we use to create the brains for digital agents. These AI factories that we're producing are the same computer that builds the brain for a physical world as you would for the digital world. But it's not sufficient. You also need the computer, a special computer that can produce the data, the information about the physical world for that AI factory to create the brain. We need to feed it somehow with information about the physical world. And because we can't get enough information from the physical world just by collecting it with sensors, we instead simulate the physical world. The video I showed at the very beginning was all about that. We turn the physical world into something that becomes a compute problem, and we can feed it. Once you produce that brain, you can now deploy it into the real world. You deploy it into a robot that has a computer inside it, inside a robotaxi, inside a humanoid robot, or the computer that you're deploying out into your factory that is controlling everything. That computer is the robot computer. NVIDIA produces all 3, and all 3 of them have to be essentially supercomputers, but in different form factors. The problem we've had with AI over the past decade is that in order to produce AI, you first had to get large amounts of high quality data. You needed to get information that you feed into this AI supercomputer to produce it. Very few companies can actually get access to the right data in order to produce that. This has been considered a moat. It's a way to keep others out from participating inside this particular space. But what's happening now is that we are turning compute into data. If we can go generate the data that we need through simulation, through playing games with ourselves inside these computers, then you no longer are limited by the data that you can collect from humans, data you can collect out in the real world. It's not just big companies that can go do this. It's basically anybody that has compute. And so we've started to see this trend. This is what we're doing as well. Essentially, this is a democratization of AI so that all companies, all countries, no matter how big or small they are, can participate. It's just a matter of having enough AI compute capacity to participate. All of the robotics companies that you see anywhere in the world, they're all building on NVIDIA. I mentioned that there's 3 computers. Most of them are using all 3 of our computers, but some of them choose to use different computers for some part. We're not offended by that. As long as they use one of our computers, we're happy. They usually at least use the AI factory. They often use the computer that's actually inside the robot is ours. And definitely if they're doing any simulation and generating data, that's also our computer as well. You can see a large number of them here of our partners, but this is not a comprehensive list. I'd just like to note in particular, there's 3 robots in here that are all part of Agile robots. There's Agile robots. Franca is part of the Agile group in IdealWorks. They're visiting us today. I don't know if they're in the audience, but there they are. And hoping to bring them over here to Armenia to come participate in the physical AI revolution inside Armenia. Thank you. Thank you for coming. So we are very, very fortunate here in Armenia. This revolution is happening worldwide. It is changing everything. It's probably the greatest technological change, greatest economic change humankind has ever experienced, and we're right at the beginning of it. And this time around, with this technology revolution, Armenia is actually in the forefront. We are positioned to capitalize on this in a way that we never had opportunity before. It all starts with AI infrastructure. We pushed for having a supercomputer here in Armenia years ago, and we now have one. We have one right here inside this institution. Thank you to the leadership at the university. Thank you to Hago Parshakian, who pushed for this from the beginning and got the Armenian Republic to actually fund this supercomputer. And now, as we heard, it's essentially at 100% utilization. Our researchers need more tokens for them to continue to do world-class research. But thank you. Let's have a hand for this. This is a big accomplishment. But it doesn't end here. We also have Elevate AI that is coming online soon. They're going to kick this up another order of magnitude with 512 of our latest GPUs. But not ending there. This is just the very beginning. Congratulations to Elevate. And then as you've all heard, we have Firebird coming. Phase 1 is going to be 6,000 GPUs. To give you guys some context as to what that means, what 6,000 is. I was with Agile Robots a few months ago in Berlin, where Deutsche Telekom, a great partner of ours at NVIDIA, announced their biggest supercomputer, AI supercomputer, coming online in Germany. And it's 8,000 GPUs. So we are already at the same level as the largest European country, the richest country, with just phase 1 of Firebird. But as you all know, when a month or so ago, when the Vice President of the United States came here, we also announced that there's the expansion of Firebird planned. The United States government has given Armenia the permission to import these GPUs. This is not something that they give to everyone, but we have a very special relationship and an opportunity here. So the next phase is going to grow this number to 50,000, which will put Armenia, in terms of not relative number of GPUs or GPUs per capita, but in absolute numbers in the top 5 countries in the world. But it won't end at phase 2. We have more coming, more phases. And with that, I'd like to end with this slide to give everybody a sense of what is already happening in Armenia in terms of high tech, in terms of AI technology. We already have a very rich ecosystem here. We not only have this ecosystem, but we now have the basic infrastructure and tools coming into play to supercharge it and to put us forward. For this revolution, we don't have to play catch up. We can be the leaders. We can put ourselves on the map as a place where world-class research and innovation is happening and make ourselves important to the rest of the world. And by doing this, by being important to the rest of the world, we can ensure that we have peace, that we can be prosperous, and that our children here in Armenia can have futures for generations and generations to come.
Thank you, Rev, for the great presentation.